Let us see the seventh sum, that is, write three numbers whose decimal expansions are non-terminating and non-recurring. So for the first one, I will take the value of pi, that is pi is equal to 22 by 7. So let us see how it works. So I'll divide 22 by 7. So 7 3s are 21. If we subtract, we get 1 point. I'll bring 1 0 down. 1s are 7 minus 3. So I'll bring another 0 down. Then 4s are 28. So that is 2. If we subtract, I'll get another 0 down. Next is 2s are 14. If we subtract, we get 6. I'll bring the next 0 down. So next 60. So I'll take it out at 8. So 7 8s are 56. We get, if we subtract 4, I'll bring another 0 down. 40. So 5s are 35. Subtract 5. So if we go on doing this, right, it will continue, and even this will continue. So therefore we can see that the pattern is not repeating. So pi is equal to 22 by 7 is equal to 3.14285, so on. It will continue. So this is one example of a non-terminating, non-recurring decimal expansion. Next, we can take root 2. So to find out the value, I'll do it using long division method to find out the square root. So let me start it. And for this, like, if you want to know how exactly the long division to find out the square root is done, there is a separate video done on this topic. You can look into that. Now let's continue. So I'll write 2 inside. Okay, so I'll take 1 1s are. So 1 square is actually 1. So if we subtract, how much do we get here? 1. So next, if I have to bring down zeros, the rule is we have to make it into pairs. So the first one was a single digit at the units place. So I just used it as 2, but when I have to get a 0 next time, I get it in pairs. So 100, and this we have to add whichever digit we have written over here. So 1 plus 1 is equal to 2. Next, we should see how much we have to multiply. So 24 4s are 16. 4 2s are 8, 9. If I multiply 25 5s are, so you can see whatever number I take here, I have to multiply with the same number. 5 5s are 25, 5 2s are 10, 125. So this is more than 100, therefore I go for this number. 4s are 96. If we subtract, I'll get 4. Again, bring a pair of zeros down. Next, so what did we multiply? So we multiplied 4 4s are. So add that 4 again, we get 28. So next we have to see 280, like how much should I multiply so that I get it near to this digit. So it is 400. 282 2s are, if we do 8 to the 16, 2 to the 4 5, it will be greater than 400, right? So I'll take it out at 1, that is 281 1s are. So 281. If we subtract 10 minus 1, it is 9. 9 minus 8, it is 1. 3 minus 2, it is 1. So next, again I'll get a pair of zeros down. So 0 0, and I have to add, it is 281 1s are, right? So add 1, we get 282, and next we have to see with which number we have to multiply, so that it can we can subtract the resulting number from this number. So this number is still small, so let me try out the next number. 4 4s are 16, 4 2s are 8, 9, 8 4s are 32, 4 2s are 8, 9, 10, 11. So I think this number is the best one, so I'll choose that. 11296. So 10 minus 6, 4, 9 minus 9, 0, 8 minus 2, 6. That's it. Now I multiplied it with 4, so I add 4 here. 2, 8, 2, 8, and next digit we have to find out. So this one goes on like this. So therefore the decimal expansion of root 2 is 1.414, so on. So even this is an example of non-terminating, non-recurring decimal expansion. Next we can also go for root 3 in the similar manner. Goes down. Now if we continue, it goes on like this. So the decimal expansion of root 3 is 1.732, so on. This is also an example for non-terminating, non-recurring decimal expansion. Now if we speak generally, we should know that for a fact roots of prime numbers are non-terminating and non-repeating. So we saw here root 2 and root 3. They are prime numbers, right? So if we see in general, if we take roots of any prime numbers, their decimal expansion will be non-terminating and non-repeating. Now again, the other set of examples that you can take is generally, like you can write 0.10100100001 00001, so on. So you can see that none of the block here repeats. So this is a general example that I can give if the question is like this. Or let me take another example, 0.02, 002, 0002, so on. So literally, like, you can take any kind of decimal expansion like this in this form where none of the block repeats. So this is an example of non-terminating, non-repeating decimal expansion.